Hey everyone, so in the previous video we were talking about that the periodic table has groups and it has periods. Generally we have 8 groups and we haven't talked about what is there in the center of the periodic table, but we know that there are 8 groups that we generally talk about. There are 7 periods. Each group number tells us about how many electrons are there in the last shell of an atom, and the period number tells us how many total shells will be there. So for the remaining shells you can just fill in the electrons on your own. You know the electrons in the last shell from the group number, but as for the remaining shells, if there are, you can just fill them on your own. And this is what we talked about in the last class, and we did some practice as well. In today's video we're going to see how the metals and non-metals are situated within the periodic table. So we're gonna copy this entire periodic table like this. We're gonna copy it and we're gonna paste it so we can understand the whole idea again. We're gonna paste it over here. We know one thing, that the elements in the group number 1 have 1 electron in the last shell. The elements in the group number, let's say 2, have 2 electrons in the last shell, and so on and so forth. So for example, if I talk about randomly period 2, we know we have lithium, beryllium, then obviously on the other side we have boron, period number 3, group number 3, then we have carbon, we have nitrogen, then oxygen, and then fluorine, and then obviously neon. Each of these elements have their nucleus, so they have their nucleus like this, and each one has 2 of the shells, because this is period number 2, right? So they have first electronic shell, then the second shell. Similarly, all of them are going to have the similar pattern, so it's same for them, same over here for boron, same for carbon, then nitrogen. So nitrogen has its 2 shells. Similarly, oxygen has its 2 shells. Then we have fluorine, and then obviously we have neon. So I am drawing the shells of each of those, and I know I'm done with them. They have how many electrons in the last shell? So now that's the question. We know that lithium has 1 electron in the last shell, beryllium has 2, boron has 3, carbon has 4, nitrogen has 5, oxygen has 6, fluorine has 7. It's a little closer, but we can put it that way. And then neon has a complete shell like this. It has complete 8 electrons in the last shell. What about the first shell? All of them have 2 electrons in the first shell. So first shell has always 2 electrons, nothing new. But it's a matter of how many electrons are in their last shell. Okay. What happens is that each of these elements want to have a noble gas-like configuration. They want to either have 2 electrons or 8 electrons, but generally we follow the rule of octet, so all of them need 8 electrons in the last shell. So generally group number 1, 2 and 3, they lose electrons and they become plus charge, they become positive charges, so that they can have a stable configuration. When we talk about group number 4, 5, 6 and 7, they gain electrons. So group number 4, 5, 6 and 7, they gain electrons and they become negative charges. Losing an electron gives you a positive charge, gaining an electron gives you a negative charge. Why this happens? This happens so that they can become noble gas-like configuration they can have, so that they have a stable noble gas-like configuration, noble gas-like electronic configuration. This is how they behave. So always group number 1 will lose 1 electron, group 2 will lose 2 electrons, group 3 will lose 3 electrons. What about group number 4, 5, 6 and 7? They will gain 4 electrons. Group 5 will gain 3 electrons, group 6 will gain 2 electrons, group 7 will gain 1 electron, group 7 does not gain or lose. And that is why group 1 will always have a charge of plus 1, group 2 has a charge of plus 2, group 3 has a charge of plus 3. Group 4 will have a charge of minus 4, group 5 will have a charge of minus 3, group 6 has a charge of minus 2, group 7 has a charge of minus 1. So generally periodic table tells us that the atoms want to lose or gain electrons depending on their group number. So group number 1 will always lose electron, 2 will always lose 2 electrons, 3 will always lose 3. Group 4, for example, has 4 electrons in the last shell, so it gains 4 generally to have a noble gas-like configuration. Similarly, group 5 already has 5 electrons. It gains 3. Group 6 gains 2. Group 7 gains 1. So this is how we know that they always lose or gain electrons. Now, one thing that we all know about the periodic table is that it has the elements in the order of groups. Group number 1, 2 and 3 are metals, while the group number 4, 5, 6, 7 are non-metals. So group number 1, 2 and 3 are metals because metals lose electrons, so they lose electrons, metals that lose electrons. While group number 4, 5, 6, 7s are non-metal, so they are non-metal because they gain electrons. So the left side of the periodic table has metals, but the right side has non-metals. So we know one thing, the left side has metals, the right side has non-metals. What about the center portion of the periodic table? The center portion is something new, that is the transition elements, or you can call them the transition metals. So the center portion of the periodic table is the transition metals. The transition metals are generally the ones which lose electrons because they are metals, but their charge is not fixed. They become plus, but they can become different values of plus. They can become plus 2 or plus 3 or plus 4 or plus 5, etc. It is not fixed for them, but at the end of the day they are metals, so they lose electrons, but the transition metals can lose multiple set of electrons which is not fixed, and they can have multiple values of plus. So far we have seen how the periodic table is connected with the charge. In the next video we'll see more about their bonding. So stay tuned guys.